uh, in the earlier lecture I talked about linear fitting. Now I will discuss today's lecture curve fitting, and here I am going to fit a quadratic polynomial to the given data and then generalize this idea, right, to fit any polynomial of any order, right? So consider data points. We are having data points x1, y1, x2, y2, and so on. And let we are trying to fit a polynomial, and that polynomial is a quadratic in nature, and say it is a naught a1x plus a2 x square. It's a quadratic polynomial which we want to fit. Into this data. So the error is, for the ith observation, error is qi, and it is represented as yi minus f of xi, as we have discussed in the earlier lecture. But we need to find out its square. So that means qi square is equal to yi minus f of xi, its whole square, and it is yi minus a naught plus a1x plus a2xi square and whole square, right? So it's simply can be written as yi minus a naught minus a1xi minus a2xi square and whole square, right? So this is the equation number 1. But what we need to find out the sum of squares of the errors. So that means we need to find out this such that this sum of squares of the error is least with respect to the parameters a naught, a1 and a2. That means we need to find out curly q over curly a naught, curly q over curly a1 and curly q over curly a2, and all must be equal to 0. So this is the condition for q to be minimum. This is discussed in detail in the earlier lecture, right? And this is basically this one, right? So it is yi minus a naught a1xi minus a2xi square, x square, right? That's what we need to do. So this is the value of the q. So let us try to evaluate these three quantities separately, one by one. So let us try to find out curly q over curly a naught, means it is curly over curly a naught summation yi minus a naught minus a1xi minus a2xi square whole square. That's what we need to find out. And let us do little algebra. So it comes out to be summation 2yi minus a naught minus a1xi minus a2xi square, and it is with respect to a naught, so corresponding to it minus will comes out to be here, and this minus 2 can be taken out because 2 multiplied by minus 1, it will be minus 1, and it is a common factor which is multiplied, so it can be taken outside the summation. So now it is yi minus a naught minus a1xi minus a2xi square, and we have equated this equal to 0 for q to be minimum. So that means that minus 2 cannot be 0. That means this summation must be equal to 0. So summation yi minus a naught a1xi minus a2xi square, it must be equal to 0. So what does it mean? That summation yi means taking summation separately. So it is minus n a naught. This is clear from the earlier lectures, so I'm not going to talk about it in more detail. It is a1 summation xi minus a2 summation xi square, and it must be equal to 0. This implies that summation yi is equal to n a naught plus a1 summation xi plus a2 summation xi square, right? So this is the one equation which I am getting. This is the relationship between a naught, a1 and a2. Let me call this as equation number 1. Now let me go to the next term. So now consider curly q over curly a1, and it is curly over curly a1. It is yi minus a naught minus a1 xi minus a2 xi square. It's summation so it is summation to yi minus a naught minus a1 xi minus a2 xi square, and its derivative rest will be 0 applying chain rule, so it is minus xi, right? That's what I am getting here. So it is minus 2 can be taken outside, and it is xi yi minus a naught minus a1 xi minus a2 xi square, and it's a summation. Now it is minus 2 summation yi xi minus a naught xi minus a1 xi square minus a2 xi q, and it's like this, and this is equal to 0. But now this minus 2 cannot be equal to 0, so that means this summation part must be equal to 0. Means summation yi xi minus a naught xi a1 xi square minus a2 xi cube, it is equal to 0. This means that summation yi xi must be equal to a naught summation xi. I just opened the summation, or bringing summation inside, so it is this one, a naught summation xi a1 summation xi square plus a2 summation xi cube, right? So this is the second equation which I am getting. So yi xi summation is equal to a naught summation xi plus a1 summation xi square plus a2 summation xi cube. That's what I am getting here, and let us call this as equation number 2. Now let me go to the next equation. Curly q upon curly a2, it is equal to curly over curly a2. It's summation yi minus a naught minus a1 xi minus a2 xi square whole square, and it is if I take its derivative, it is 2 yi minus a naught minus a1 xi minus a2 xi square into minus xi square, right? Its derivative rest will be 0. I just simply applied the chain rule, so need not to talk about it in more details, right? So it is minus 2 can be taken outside, and here I can write down this xi square can be multiplied inside it. So if it is multiplied, then it will be it is yi xi square minus a naught xi square a1 xi cube minus a2 xi raised to power 4, and its summation, and it is equal to 0. And this means that minus 2 is not equal to 0, so that means this must be equal to 0. Means summation yi xi square minus a naught xi square minus a1 xi cube minus a2 xi 4, it must be equal to 0. That means that summation yi xi square minus a naught summation xi square minus a1 summation xi cube minus a2 summation xi raised to power 4 is equal to 0. This means that summation yi xi square is equal to a naught xi square plus a1 summation xi cube minus plus a2 summation xi raised to power 4. So this is the third equation which I am getting. So let me summarize these three equations together. Let us summarize the result. So if I summarize these, then it can be a naught n plus a1 summation xi plus a2 summation xi square is equal to summation yi, then a naught summation xi plus a1 summation xi square plus a2 summation xi cube is equal to summation yi and xi. Here I am getting summation xi square plus a1 summation xi cube plus a2 summation xi raised to power 4 is equal to summation yi and xi square. So these are the three equations which I obtained. So if we solve these equations simultaneously, then we can obtain the values of a naught, a1 and a2, and a required polynomial can be obtained. And we get a very interesting pattern here. Say it is a quadratic polynomial, so it is simply like a polynomial. Now what here we simply multiplied with every term with the xi, so it will become xi here, and here it has xi square and xi cube, and in this side it is xi, and with here xi square like this, right? So we get a very interesting pattern. So I will generalize this pattern for the fitting a polynomial. So if we want to fit a polynomial of nth degree, say a naught plus a1 x plus a2 x square and so on, am x raised to power m. So it is a polynomial which we want to fit. So if we want to fit such a polynomial, then required relations can be generalized in the same manner as we have discussed earlier, right? So it is a naught n plus a1 summation xi plus a2 summation xi square and so on, am x I raised to power m, and summation will be here, right? And it is equal to summation yi. Then I can write down a naught summation xi plus a1 summation xi square plus a2 summation xi cube plus and so on, am summation I m plus 1, sorry, summation will be there, is equal to summation yi and xi. And here I can write down a naught xi square plus a1 summation xi cube plus a2 summation xi raised to power 4 plus and so on, am summation xi m plus 2 yi xi square and so on. We keep on doing in this manner. In the last we are getting a naught xi raised to power m plus, sorry, summation will be there. Yeah, it is a1 summation xi m plus 1 plus a2 summation xi m plus 2 plus and so on am summation xi m, it will become 2m is equal to yi x raised to power m. Thus, we will obtain m plus 1 equations, and using these equations simultaneously we can determine the values of a naught, a1 and am. Thus, any polynomial can be determined using this method. So this is a very interesting method to find out. So let us understand the fitting of a quadratic polynomial. Using example, I have taken this example from the book by Bala Guruswamy, Numerical Methods, right? So the problem is that you have to fit a polynomial, fit a second order polynomial. The data given below, and the data is given as x and y. The value of x will be 1, 2, 3 and 4. It is 6, 8, 6, 11, 18 and 27.0. Let me recall the equations. As I know that the equations which are needed for the quadratic polynomial, that is a naught n plus a1 summation xi plus a2 summation xi square is equal to summation yi, and it is a naught summation xi plus a1 summation xi square plus a2 summation xi cube is equal to summation yi xi, and here it is a naught xi square plus a1 summation xi cube plus a2 summation xi 4 is equal to summation yi xi square. So that means we need to evaluate summation xi square, summation xi cube, summation xi 4. We need summation yi, summation yi xi, and we need summation yi xi square. So these the things which we need to find out. Once we know these things, that means these three equations can be obtained and can be solved simultaneously. So for this, let us proceed as follows. So it is xi, another value is yi, and then what is needed? It is xi square, then xi cube, xi 4, then yi xi, and yi xi square, right? That's what is needed. Okay. These are the things which are needed here. So let us do little algebra or little mathematics, and once we do that, we are able to find out the things very easily. And here I will write down the summation of all these things, and the things which were given to us are as shown here. Yeah, so it is 1. Yeah, these are the 4 values. Okay, 1, 2, 3 and 4, right? So this is 1, this is 2, sorry, let me take another color, right? So it is 1, 2, 3, and 4, and here it is 6, 11, 18, and 27. Now let me try to find out xi square. So it is 1, 4, 9, and 16. It is 1, 8, 27, and 64. Then it is 1, it's 16, it is 81, and it is 256. Now I will multiply this with it, then what I am getting, 6, 22, it is 54, and then it is 108, and here xi yi square, so that means this gets multiplied with it, so it is 6 again, it is 44, it is 162, and this into this will be 432. Let me find out their sum, because here I am interested to find out their summation. So it is 10, it is 62, and it is 30, it is 100, it is 354, it is 190, and it is 644, right? So that's what I am getting here. Let me do one thing. So if I put all these values here, and another things, let me put all these values here. So if I put all these values in this equation, then I am getting, because there are 4 values in all, because n will be 4. So it is 4a0 plus 10a1, and then I put its value here, so it will be 30a2, and it is equal to 62. Then similarly I will obtain another equation. It is 10a0 plus 30a1 plus 100a2 is equal to 190, and then I am getting 30a0 plus 100a1 plus 354a2 is equal to 644. Now we are having 3 simultaneous equations, 3 unknowns. So if I solve these simultaneously, we obtain a0 is equal to 3, a1 I am not solving, you can solve it at your own, and a2 is equal to 1. So that means we can obtain the required quadratic polynomial. So what is the required polynomial? Required polynomial is that y is equal to 3 plus 2x plus x square. That's what I am getting, right? So thanks for watching this lecture.